Yep.
Yes, we do.
It's a bit low.
It's very low. Is that master? Hello, 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 hello. Very loud. That's annoying, that's annoying. Because otherwise the speakers also go hilariously loud, right? Isn't there a track output?
There is a track output.
But can't we just fiddle with these now? We hebben nu audio en ook in de stream, maar hij is een beetje laag. Beetje laag, laag, beetje laag. Ja, maar die is nog lager. Geen idee. Deze, nou, het is meer waar dit uitkomt. Deze komt hier uit. Two-track USB input-output. Ja, ik denk het. It's probably which is annoying, gazoing. Annoying, annoying.
Because I mean, I can't push it a bit and the video makes a
No, but then you get probably
noise on the front end.
yeah. Okay. Maybe Pat has an idea.
Because the thing is the two-track slider doesn't seem to
Doesn't have USB out?
He does, but that doesn't help us.
No? No audio? Or you can't do audio in that?
No, I can't do
USB.
USB only. I mean, I can connect my laptop to it and then, but I would prefer not to, because I don't think that would make anything better.
Or
Because the thing is that's definitely the slider for two-track.
Yes.
It doesn't seem to change anything.
no, not at all. Annoying, gazoing. Geld geven? Ik ga zo even kijken wat er nog over is. Ja, maar het valt volgens mij. Albert, do you need to eat?
At some point it would be good, yes.
Because I think the line is not that big anymore. unmute one? Hello, hello. No, that's not this one. Hello, hello. Yep.
Hello.
So that's two. This is one.
Cool, cool. Hi. First of all, a big thank you to the FreeBSD Foundation, who has been sponsoring this work and continue to sponsor it. So, who am I? I'm this messy geek who has been messing around with computers since the early 1980s. I've been working in antivirus software, high-end video conferencing, malware and vulnerability research, a bit of penetration testing and security auditing, and now I have got the idea that I should help try improve Java for OpenBSD, no, for FreeBSD actually, the other one. So when I try to tell people what I'm doing, what my work is these days, I get two questions. The first one is anyone still using Java? So I keep telling people that, yeah, there's people who still use Java, and there's a good chance that even the systems you rely on is using Java. For some, unfortunately, yeah, but for others, it seems to work fine. The next question is, what on earth is FreeBSD? So you try to explain to them, yeah, it's a Unix-like operating system, and say, oh yeah, it's a Linux then. No, not quite. And you try to go into details and explain to them the history of Unix and stuff, and you just see their eyes glaze over and they zone out and start thinking about peeling potatoes or something, I don't know. So, about the project, we have essentially one major goal, and that is to make FreeBSD a first-class supported platform for the OpenJDK. And that will mean that we need to bring the BSD port up to date with the OpenJDK mainline. We have to make sure we can pass the tier 1 test at the bare minimum. We should, of course, try to go beyond that, but that's the absolute minimum of what we have to achieve. We have to bring the changes back into the upstream project so that we don't have to port it to FreeBSD every time there's a new release. And then finally we want to add any missing features to the FreeBSD port. That's not finally actually, because there's one more step we have to do, and we have to pass the Java conformance test to see that we are actually proper in Java. The scope of the project is OpenJDK on FreeBSD and targeting AMD64 and ARM64 architectures. This does of course not mean that I want to break other BSDs or other targeted hardware architectures, but these are where we focus, and to be sure that we can ensure that it works on other systems too, I will probably need some help going forward. So where are we on the project? I've been working on this for about 10 months now. Yeah, about 10 months. And we're still out of tree. That means we have to port all the changes from the OpenJDK into our branch, into our separate repositories. But the infrastructure is in place, so we can begin the work on upstream with an app. It has taken us quite a bit of time to get there. A lot of it has been I needed to learn and learn how to communicate and how to work with the upstream OpenJDK project, but also it has to be getting the right people to respond to emails and actually take things further. So, about our goals. We want to bring the BSD port up to date with the OpenJDK mainline. The good news is this is mostly done. Yay. Mainline is pretty much in sync now. I still have some outstanding issues with the JDK25 port, which is the reason it's not yet in the port tree. JDK24 is pretty much up to date with mainline, the FreeBSD related changes in mainline. So that's a pretty good port to be based on right now. Older ports will be maintained as needed and on a best effort basis. We need to make sure we can pass the tier 1 tests. This is also mostly done. I started off by porting the internal testing framework, the JTREG testing framework for FreeBSD, and added a FreeBSD CI run to it. This is a bit interesting because it uses GitHub Actions, which doesn't support FreeBSD. So what we do is we spin up a Debian machine or something which runs a VM, which runs FreeBSD, and then we run the tests in there, inside the GitHub Actions thing. It's not ugly, it is actually quite ugly, but it works most of the time. We have improved test coverage on FreeBSD. When I started, I had about 140 failing tier 1 tests. Now we're down to 3. Unless we run on ZFS, which gives us 5. I'll get back to that. But anyway, even 140 isn't all that bad. This is out of about 10,000 tests that's running. And also I managed to get the ARM64 and AMD64 ports on the same level when it comes to the tests. This was not the case when I started. And most of the fixes I've done to the JDK itself has been driven by the failing tests. So, to bring the changes to the upstream project, this is mostly future work, or what I'm going to start on now. There's feedback. But I've done a few things. There's some stuff I managed to upstream, and those have mostly been not directly BSD related, but stuff that's useful for our ports, like adding configure arguments to find libraries and being able to parameterize typical compiler switches and stuff that differs between the different platforms. And we have finally OpenJDK BSD port repository where we can start the work of doing the upstream. This is a repository that's owned by the OpenJDK infrastructure, and we'll use all the OpenJDK tools and workflows to work with. So that's a pretty good start for us. Adding missing features, that's also mostly a future thing, but I accidentally stumbled upon some ifdefs that disabled IPv6 dual protocol support, so I just removed the ifdefs and it sort of works. And yeah, this should be by now at least in JDK 24 and 23, and of course in 25 when I get it out. It may be in some earlier too, but I don't have the full overview of that yet. But it's probably something that will be backported to other earlier versions as soon as we get to it. Past the JDK compatibility conformance test, that will be future work once we are in the proper repository. So yeah, I've done quite a number of fixes for FreeBSD. Most of them are kind of internal to the OpenJDK, but useful. It's like I fixed the symbol lookup for backtraces on crashes and in the serviceability agent. The serviceability agent is the way debuggers and other tools connect to a running Java program or JVM and to extract information from it. And backtraces are a lot more useful when you actually get proper symbol resolution from them. Also, and related to that, I had to work around that the internal APIs in FreeBSD for demangling C++ symbols. We're quite happy to try to demangle undemangled symbols, which gave us pretty weird results. So I just have a really crude filter in front and say, does this look like it's mangled? If that, we send it to this API. If not, we just return the string as it is. I fixed traversing stack frames on ARM64. This is a quite tricky thing because Java has, of course, in addition to Java code, you have compiled Java code, and in addition to that, you have native code that's either from the JVM itself or from other native libraries or JNI injected code or lots of stuff like that. So it's a lot of back and forth and trying to figure out how things are. There was some vital pieces missing there on ARM64. And I've did a quick update of the code to find thread execution time for arbitrary threads, and that's something that garbage collection team was asking for. I fixed allocating heap on file system paths. You can, using this XX allocate heap at argument, you can tell OpenJDK that you should use this location mapped into the file system to store the heap, the Java heap, presumably for some sort of persistence or something. That did not work. Now it does work, but it does not work on ZFS because ZFS cannot guarantee that you have that space available because it's a copy and write file system. An interesting part of that is that Linux using BTRFS, for example, can also not guarantee that, but glibc will just say, well, it's probably all right. And macOS doesn't care at all. They just say, yeah, go ahead. And then there was a lot of other, different fixes. It's not all that important, all of them. The BSD port project, this is the OpenJDK project for the BSD port. It's in revival mode, which means we are trying to get it up and running again. There was a BSD project a long time ago, and it seems pretty dead now. The mailing list has, the only response I've gotten on the mailing list is from other OpenJDK people, not from BSD people. So that's interesting enough. But we have a GitHub repo, as I mentioned, established, and we need to write a Java enhancement protocol proposal, which is kind of just a document explaining what we want to do, and adding a new supported platform to the JDK is one of the things that requires such a document. And how we will work with this is moving all the changes we have now over to the OpenJDK hosted repository, and from then on we will just keep merging in the changes from OpenJDK, so it will be much easier to keep things in sync and keep tracking the different changes. And once this is all done and we got the Java enhancement proposal accepted, the port will essentially be merged as one go. But by then we should have CI and everything up and running. So what have I learned during this time? Quite a lot. There's a lot of minute, strange differences in low-level APIs between different platforms, which shouldn't surprise anyone. I spent a lot of time on figuring out how both FreeBSD and glibc, which is mostly used by Linux, loads shared libraries, how they look up symbols and all that stuff to try to find the backtrace fixes I needed. It seemed in the end that wasn't relevant at all, but I spent some time on it. There's a lot of esoteric compiler switches I haven't used before, which is interesting in itself. Also, during the discussions around the IPv6 dual protocol support, I learned a lot about different TCP/IP implementations, the history of it, how they relate to each other, and what kind of trade-off the different people or different groups have come through. I've learned about how FreeBSD implements pthreads and generally about threads. Quite a bit about the port system, of course, how stack guards work on different platforms, and how OpenJDK uses this to be able to send Stack Overflow errors back to the program without terminating it, and how FreeBSD, with its own stack implementations, somehow gets on top of the OpenJDK causes issue for this. So we have some code in the signal handler that looks, are we in the stack guard for FreeBSD? If so, we just ignore it and look if we add the size of that stack guard, would we be in the OpenJDK stack guard? And then we treat it like a Stack Overflow error. That's an interesting piece of code. I spent some time trying to figure out why is it there and how does it actually work. Yeah, and of course I had to learn a bit about how Java deals with bytecode and native code and compiled code, and a bit about ARM Art64 architecture. I had to also delve into the dark corners of AutoConf and a bit on M4, and to filter emails. There's a lot of traffic on the hotspot lists. It's it's like easily 200 mails or more a day. So there are some of the issues I've come across. One of the things that's really difficult is Oracle requires that everyone who submits code to the OpenJDK needs to be covered by a contributor agreement. So you have the Oracle contributor agreement. So for every change we have that I don't know exactly who is behind, I have to trace it back to see where does this line come from, when did it enter the code base, who actually inserted it, and are they covered by the OCA? And especially the last part is a bit difficult. And what makes it even harder is that OpenJDK forks the repository every time it releases a new version. So like OpenJDK 25 that was just released now, that is released from a branch from the main OpenJDK repository. But then the future updates to JDK 25 will be from a separate repository called JDK 25U, which is for update. And what happens is, of course, we need to bring our FreeBSD related or BSD related changes over to this, and that is usually done as one big commit, which effectively just erases all the blame log, and so it makes it hard to trace beyond these points. The oldest code I've found with actual repository information is JDK, the port for JDK 7, which is in a set of old Mercurial repositories. Mercurial is fine enough, it's just I'm not so used to using it, and crossing these boundaries between Git and Mercurial is a bit challenging sometimes. Some FreeBSD specific issues. The way we handle bootstrap JDKs is a bit suboptimal, in my opinion at least. How it works now, first to explain a bit, the JDK is partly written in Java, which means that we need Java to compile Java. And the way this is solved in the OpenJDK is that you have what's called a bootstrap JDK. And this is a JDK, you point your, you tell the configuration script where is the bootstrap JDK, and it will use that. And it has to be either the previous version or the current version of Java, the current major version. So what we do on FreeBSD is that we make the port depend on the previous version of the port, which means if you try to install one JDK, you will get the previous one and the current one. And since the previous one also depends on the previous, there again, you get another one, until you get to a place where you have a boot JDK, which is a separate thing, where they essentially does the right thing by downloading a precompiled OpenJDK, and you can use that to compile. But also, in this case, this is installed into the system, so you will get the boot JDK, which you will not ever use, installed on your system, including all the ones between that and the JDK you want to install. So I have some reviews out for finding a way to do this in a more elegant way, where each JDK will just depend on its own boot JDK, which is precompiled and is used directly in the build process, but never installed to your system. Another issue is a package command does not care if you have a compatible JDK installed. So let's say I have a program that requires OpenJDK or Java, and I want to install that. It doesn't specify what version of Java it needs, but it needs Java. I have Java 26 on my computer, but let's say something more rational, Java 24. And PKG will tell you that, yeah, that's good. You also need Java 8, which is like 10 years too late, at least. So that's things I think we should look into and try to fix on the FreeBSD side. Also, I was suggested by Sven that having an opportunity to set both the minimum and maximum compatible version, Java version in the ports would be a good thing, and in addition perhaps also preferred Java version. So you can kind of see if you have any of those installed, good, we don't need to install another one. And if you don't, then we install the preferred Java version. And also I'm wondering, do we really need to support every OpenJDK version? We know there's probably some gaps in there, but it's like from Java 8 to Java 25 in hopefully a week or so. It's like, do we really need that? Or would it be better to have like the latest LTS or a few LTS versions and maybe the latest going? And also I'm wondering if we need a separate port for each JDK version, or if we could combine that. We had some issues lately where some earlier Java JDK versions had problems, got into some problems on the PKG build servers. And essentially after some debugging, there was someone on the mailing list who did that. They figured out that the problem was a fix that we had actually done on the latest port make files, but it hadn't been brought back to all the other ones, and that's why this happens. One of my main motivations for talking here today is actually to try to inviting collaborations, especially with other BSDs. As I said, I'm sponsored by the FreeBSD Foundation, and as that, my scope is on FreeBSD. But the BSD port traditionally has been a cooperation project between the various BSD, especially OpenBSD, and also I think NetBSD has been involved in it. So it would be really good to kind of get a group together or find some way that we can ensure that we don't break the other BSDs, because I don't think anyone is actually have anything to gain by doing that. But it's also hard for me to both get the time and spend time on like testing and making sure that the other BSDs work. So I'm encouraging anyone who's interested, whether they are from other BSDs or are just interested in the FreeBSD port, to join the BSD port dev mailing list. Or you can also join the FreeBSD Java mailing list, but at least the BSD port is meant for the entire BSD port project. So that would be really, really cool. So that was it, I think, more or less. A big thank you again to the FreeBSD Foundation, and also to the OpenJDK project. I feel I've been welcomed quite nicely with them. They've been both welcoming and supportive. Also to Greg Lewis, the lead of the OpenJDK BSD port project. Is sometimes a bit tough to get hold of, but he's always helpful and nice when we do get hold of him. And also to all the people that has been helping me from the FreeBSD Foundation, that with all the strange stuff I need help with sometimes, whether it's ports or just how do we do things in FreeBSD things, or yeah. So that, again, join the BSD port mailing list if you're interested. If you send emails to java@freebsd.org, you will reach me and other people that works with Java. I'm also available on the Fediverse as Harald on my own Obsiva instance. So actually I did this faster than I thought. But anyway, does anyone have questions? Discouragement. Oh, discouragement.
What was the most difficult question, kind of difficult problem or most challenging thing that you had to solve?
Yeah. The question is, what was the most challenging or difficult problem I had to solve? It's a bit hard to say, as I still have some problems that I haven't solved. But yeah, some of the difficulties is in that Java or the JVM is essentially an operating system in its own right. And it uses very much of the low-level APIs that are provided by whether it's Linux or Windows or FreeBSD or whatever. So I spent a lot of time on that stack trace thing and just to figure out the flow of the code. How does it go all the way down to where it is? And of course, I didn't mention, but this also includes reading core files and parsing ELF files directly and trying to pick out all the information directly from them, in addition to looking at how the operating system is doing it. And so it's a lot. I think in general the complexity of it has been the most difficult.
Hello. Have you found bugs in upstream? Bugs that were present but not exposed and that your work uncovered?
I'm not able to hear because I'm behind them. Let me go.
Okay. Have you found bugs in upstream?
If I found bugs in upstream, I found things that doesn't work as it should on FreeBSD at least. And I found things that look strange, but not downright bugs, but I found things that probably can be optimized a bit. But in general, I think the code quality of OpenJDK is really, really good from what I've seen. But it's also an old project, so yeah, I can't remember any bugs that I found at this moment. Maybe some small ones, but I don't remember any specifics. Anyone else? Oh.
I'm curious about the ZFS, RFS allocation things. Is this something that nobody has cared about before? So the discussion, should I start over?
I can repeat.
Okay.
Allocating the heap in the file system. I don't really know if this is something that people haven't cared about. I think people care about it, but I think there's different trades off on different systems. From what I understand, the thing is that this code is in part very platform specific, and in part it falls down to like, yeah, this is POSIX, we do it the POSIX way. And then it falls down to a function called POSIX fallocate. And that's the function who has this very strict requirement that you have to, the underlying file system have to provide and guarantee to be able to provide this space availability for as long as the process is running. The glibc implementation of that function just says that, well, if the underlying operating system doesn't support this, we emulate it in our own part, whatever that means. I haven't looked into the details. OS X, I think, just has some specific APIs for it, if I remember correctly. I don't remember all the details of the source code right now, but and I think OpenBSD just does truncate, but I don't know if they have these copy and write file systems either. So and if you don't have that, that should be fine. But for FreeBSD, the code has kind of fallen through to this POSIX fallocate. So the question is, should we can, I have a patch that just changes this to use the same as OpenBSD, for example. But I'm not sure if that's a trade-off we want to do. So yeah, there's a question up there too. From the man with a nice beard.
It's more an offer for help. The IPv4 versus IPv6 problems have been there in Java. I can't remember if it was when we added multi-IP jails or when I did IPv6, but I remember looking at Java to fix that problem. So if that is still a problem 15 or more years later, I'll be happy to find my old notes and help you fixing that.
Yeah, you were talking about the IPv6.
So you had the someone disabled IPv4 or IPv6 problem.
Yeah.
That is, it sounds very much exactly like the same thing people have been doing more than 15 years ago, because Java wasn't otherwise working properly, and
yeah,
we had that fixed once.
I think the argument against IPv6, IPv4 dual stack or dual protocol sockets is that on FreeBSD you can bind to the wildcard address and still be able to bind to a more specific address on the same port. And that's not ideal for security. But I also feel this is not a Java problem. But there's arguments. But in any way, you can always disable it if you don't want it, then you're stuck with IPv4. Unless you also open a specific, all right, open a specific specific address, IPv6 address yourself, or bind to that. You can always do that. And this is only a problem when it comes to the wildcard, binding to the wildcard address. It's not a problem if you bind to specific addresses. Then you will get either an IPv6 or IPv4 socket, depending on which address you bind to.
Any more questions?
There's one there. See if we can hear what he says.
I want to ask more about this support, because if it will go into mainline, will it be still like your responsibility to keep it up working? What I mean that Java also has its own release cycle. It's pretty fast now, like every 2 years, new long-term release. And let's say we mainline the code, so something breaks, they will be contacting you to fix it. How the maintenance will happen when it reaches the mainline?
Yeah, I think what, if I understand you correctly, you're wondering if once we are merged with mainline and FreeBSD port breaks because of some change done by the upstream project, who will they call?
Yeah,
Basically.
yes.
I think their first call will not be Ghostbusters, but the BSD port mailing list. And that's where they will most likely get hold of us. And also I've gotten some private direct emails from OpenJDK people asking about the BSD specific questions already. There's actually quite a lot of people in the OpenJDK community, among the core OpenJDK developers, that doesn't actually know that FreeBSD is not a supported platform yet. Because they just assume that, BSD should be, of course, supported. So that's good. And they really give off the impression that they want BSD support to work and be a supported platform. They're really keen on that.
What kind of tests does this conformity or conformance testing include?
I haven't looked in detail on. The question is what kind of tests are the conformance suite running? And mostly this is, as I understand it, a test suite, not necessarily of technical things, but that the Java language and virtual machine does what it's supposed to do. It's like a black box test, from what I understand. So it's that when you have this kind of construct in Java, then this kind of code should be generated or something. Yeah. I haven't looked into it yet.
Any more questions? Yeah.
One there.
Thank you. I have to come back to the question with IPv4 and IPv6. Sorry, I have to ask this. You said there's a problem with a dual stack socket. So could you also fix the problem by just disabling IPv4?
Well, I assume that should be doable, but how the OpenJDK code is that it will create a socket, essentially an IPv4 socket, and then say that, well, we can accept the IPv6 too, I think. I don't know, but I don't think that's a supported configuration in OpenJDK as it is. So if we want that, we probably have to make that into like a Java enhancement proposal and go through that, which is doable. But after we got the port mainlined.
Thank you.
Anyone else? If there are no more questions, we have a small gift for you.
Oh,
the speaker. Yeah.
Well, thank you to everyone, and
yeah,
cool to see people showing up. Thank you.
Yes. Yeah, it's a necktie.
I don't have to explain to you what network emulator does. And actually, it's a GUI tool, so it's written in TK programming language. It's an old stable programming language. Actually, well, as it's a GUI tool, it's actually calling other tools and doing other things on FreeBSD. Actually, I'm running this presentation from Immunes, so you can see up here we have some menus. I'll show you some of this later. I can just disable IPv4. There are a couple of node types I can put on the canvas here, so I can just click it and it will show up. I can just terminate the experiment. I can, delete them, use the link tool to link them up, and stuff like that. So yeah, we'll get to that when the demo comes, but first of all, the emphasis on this tool is on network emulation, so not really on simulation. What I mean by that is every element, almost every element here is emulating something. So the routers really route packets, switches really switch packets. Packets are real network packets. Network interfaces are real network interfaces. And down here you can see a simple topology made out of a couple of routers, servers, switch, PC, and of course links connecting them. And yeah, this is all done in GUI, and this is all drawn here. Let's get back in time a bit to 2003, circa, when Marko Zec, he's a FreeBSD kernel developer. Some of you probably know him, certainly know him. He created something called Vimage. I already heard people talk about it. Basically for a project with Boeing, and Vimage or VNet actually became a part of FreeBSD kernel in version 12.0. He actually worked here on FAIR at the Department of Telecommunications, so he integrated this prototype of Immunes in a couple of classes here for students to be taught about networking basics and more than basics. And after a while, Ericsson, Nikola Tesla, and FAIR started a project where Ericsson actually needed to emulate some network stuff in their labs. They used their Immunes to prototype stuff, so that's where I actually got employed and started working again here at FAIR after graduating. And I worked here for 10 years where I got my PhD. So this was my first job. My first job was maintaining, developing Immunes for Ericsson Nikola Tesla. Well, projects end, people leave, and I was practically the only maintainer or developer of Immunes left. I was working here as a teaching assistant and as a side job developing Immunes as my hobby. So when I eventually quit working at FAIR, I still was the only developer, and I still had Immunes as a hobby project. And actually, when I got employed at my current employee at 5x9 Networks, we do networks, and my friend and colleague Karlo Milicevic suggested that Immunes could be actually a useful tool for stuff we do at work. So yeah, we started not only keeping Immunes alive by maintaining some basic stuff, but actually implementing new features, fixing better bugs, more bugs than ever before. And now, well, we meet almost every Tuesday after work where we discuss Immunes, do whatever we need to do, so fix bugs and develop new stuff, and yeah, generally have fun. So to recap, what is Immunes for? Teaching, training, onboarding, lab testing, prototyping, and fun. That's basically all that is, unless you can tell me something more, so we can try that also. Let's get a bit more technical. So how does Immunes actually work? Well, it started on FreeBSD, but we eventually ported it to Linux. So I'll just be short about Linux. It works with some Linux-specific tools with Docker, Podman, with Linux Bridge and network namespaces. But on FreeBSD we use, of course, jails, specifically nested VNet jails, and netgraph. Who knows what's netgraph? Okay, so enough of you knows what's netgraph. So the other people who don't know, you should just Google it and learn about it more. Okay, there's something else we mentioned every time we use Immunes. That's something called the vroot. We call it, it's short for virtual root, basically. On Linux, that's a container image, which we use to basically clone all the network nodes as we needed. And on FreeBSD, that's basically FreeBSD, basically an installation of a FreeBSD base with a couple of needed tools to make everything work, and along with some nullfs, unNFS magic, we clone that and use it with multiple nodes. So this is just an overview of the node, the experiment in Immunes. So actually, first, what we see here is just a GUI representation of a configuration file. It's in JSON, it's a plain text, so you can edit it, you can do whatever you like. But Immunes is basically, first and foremost, the GUI representation of that, while not running. But after I click experiment execute, or Immunes actually runs the experiment and deploys it. So first thing it does, it creates something basic, so just an experiment jail, in which everything is actually, everything else is actually built. So in this example, we have, do you see my cursor? Okay. You see a couple of router jails, a PC jail, host jail, some netgraph. Everything you see here, starting with ng, is netgraph. So you see netgraph nodes, netgraph ng pipe, and yeah, practically we use this experiment jail to isolate all the other jails from each other and from the host machine. So, of course, we can use some special nodes to connect with the host machine and with each other, and I'm going to talk about that a bit later. But default is that every experiment is isolated from each other, and each experiment has its own ID by default. So first, you see by every interface of every node, you see something called ng A-face. So that's a netgraph node, which represents an interface, so regular Ethernet interface. So for those of you who don't know, netgraph nodes have hooks, one or more hooks. So this ng A-face has one hook called ether, or ether, I guess, which then connects to this ng. Yeah, sorry.
Why is there a pipe in between instead of directly connecting from the ether hooks?
Just a minute. Okay, we have an ether hook connecting to an ng pipe with a lower hook, and then the upper hook is connected to another interface. So this means that packets go through the ng pipe. So the gentleman here asked, why do we need those pipes, I guess? Okay, so we have here an example of a direct link, which doesn't use ng pipes, so we can actually just select or deselect this direct link and enable those interfaces to connect to each other. without pipes. So why would you want to have ng pipes? That's a great question. So ng pipe enables us to configure some link elements such as bandwidth, delay, bit error rate, and stuff like that. It's good for simulating different link properties. So if you want to add a delay to a link, I think you cannot do that or not quite easily with direct links. So that's why we have ng pipes, which is specifically done to do that. So yeah, that's the main reason we have it. And actually, this was the default. So ng pipe was the default version of links on Immunes for quite a long time. I think we enabled direct links just last year or something like that, because why not? Okay, I think I'm louder now, so I will be a bit quieter. Sorry, yeah, we have those two nodes down here. Those are special nodes which I mentioned. So this one is called an external, external connection. It's basically an ng A-phase, so practically a regular interface, which in this case creates a regular interface on the host machine. So that means we are having this interface connected to an ng bridge inside of the experiment. So if I run this experiment, we will get a regular interface on our machine, and we can reach inside of this experiment. Similarly, there is this type of interface called, this type of node called external interface, which does something opposite. So actually it steals the real interface from the host machine and inserts it into the experiment jail. So in this case, this jail over here, so host one, would have stolen the EM2 interface from the machine and use it as its own, so it can reach the internet if it wants to. So we can just select any of those we have available, and when the experiment is executed, we actually get what we put it here. So is there any questions with this for now? Okay, when you have any questions, if you have any questions, just holler. Okay, next, a short bit about virtual root. So I mentioned vroot is practically an installation of FreeBSD with a couple of useful tools installed. It's in directory var immunes vroot, and we use this with every experiment in a way that, so each experiment gets its own directory, and inside of it we create something we call upper directory. For every node we create, so for every jail we create two more directories. One is inside the upper one, and one is inside of this experiment directory. And actually, this one will be easier to explain. We have one single node. We mount read-only nullfs of vroot over the N0 directory, and on top of that, we mount the upper N0 directory as unionfs. This means that, again, each jail, each node has its own file system practically. It has its own base. It has a single vroot base, but all the diffs are practically their own, and this means isolation again. This means since it's copy on write, it's lightweight, it's fast, and yeah, it's pretty uncostly at resources. So we can have lots of these nodes at the same time, running at the same time. Yeah, well, I think you said that unionfs is not really stable, and I agree, but Immunes uses it for 20 years or more now, and we found, and we always find some bugs, and I agree with you with that, and I'll get to get to that a bit later, and you can talk to me about UNFS more later. Okay, that was my talking for now. I would just like to show you a short or maybe longer demonstration if you like to see something more. This is just practically some basic stuff, but there are lots of things here to unpack, and actually there's not enough time for me to show you everything, but you can find me later at a coffee break, and we'll go through everything if you want to. Okay, so as I mentioned, first things, I can execute the experiment, and actually I'm gonna just check and enable auto execution on these two nodes. So when I run execute, only those two nodes are active, and you can probably see a little red dot here. What that means is that I can double click on each of these nodes, and it will open up a shell script, a shell terminal, or I can just, you know, open some other, for example, bash, and stuff like that. But first, I'm gonna just check. I had a script running, but it crashed because something wrong happened a bit before, where I have ngctl running in the background, and actually exporting everything as a graph node, but currently it's not on. Oh yeah, I know why. Sorry. I'll just restart it and start again. So okay, yeah, that's it. So what I have in the background is practically something that exports the nggraph state as a dot graph. So using this ngctl netgraph control tool, we just export it as a graph, and you can actually see in real time when I change something in EUNS, how it's represented in netgraph as a dot graph. So pretty simple topology here, two nodes. Oh yeah, I will just pin it. So two nodes connected to each other using this direct node. So we see a netgraph A face and another netgraph A face connected through those two hooks, ether hooks. So I can actually just change this to non-direct link, and you can see the ng pipe appearing here, and yeah, I can show you what I started earlier. So I can just ping. Yes, I'll just resize this. I think. So actually, it's not really important. You just need to see that the traffic is flowing. So it's a simple ping command. And yeah, as I said, I can just change the type of the link, and everything is still going live. I'll just pin this too. What else I can do with this? I can open a TCP dump on this interface here, listening, so you can see the traffic flow live, or I can open a Wireshark window on this interface, and yeah, again, you can see that the traffic is still going as it should. So nothing extra special going on over here, just opening some existing tools. And but yeah, EUNS enables us to do this more in a simple way, and that's quite important when working with students, actually. So students are not very interested maybe not very interested in doing this, so you want to enable them to do stuff as painlessly and simply as possible. So to stop the node, you can just right-click on the node and stop it. And I guess I stopped both of them. But yeah, if I want to start it, I just start the node, and it's simple as that. There are some other options here which I can do. So, for example, if I double-click on the node, this is a configuration for that node. So there are lots of options here. And for example, this interfaces opens up each interface for this node. So this is currently only the ETH01. We can change whatever we like here. So MTU, MAC addresses, MAC address, IPv4, v6 addresses. We can add new physical interfaces. Well, not physical per se, but in this context, it's physical interface. It's not logical. And yeah, we can add logical interfaces on top of physical ones, change their tags and whatever. So actually, this router over here has specifically that configured. So it has two VLAN interfaces, each with its own IP address, one on VLAN 6, one on VLAN 7. Routers are running FRR routing. It's a program. It works on both FreeBSD and Linux. It runs daemons. Specifically, these two routers are running RIP-NG daemons. So it's a simple routing protocol, but we have support for OSPF, BGP, LDP. Everything can be run inside. And something more advanced is down here. So you can actually enable custom startup config. So if you don't want Immunes to do configuration of each node for you, you can actually enable this custom startup config and create your own practically shell script, write your own whatever you like. And there are two hooks currently. So after creating interfaces and after creating and starting the node, this shell script will be started and executed as it would in a shell script. So I won't do anything now, but I'll just start these little batch over here and disable these guys. So actually, just starting it. So if anything seems a bit slow, that's because I'm running on virtual machine with 4 gigs of RAM and 2 cores. So yeah, it should be slower with a couple of more, it should be faster with a couple of more cores. Actually what I wanted to show you was, so what I explained a bit earlier. So we have vroot. So for this topology down here, we have vroot mounted on all of these nodes, so N16, 17, and so on, as nullfs, as read-only. And on top of that, we have the upper directory mounted on the same directory as unionfs. So that's basically it. And running jail list, you can see there is a single jail as a top jail, and all of these as their children, as these jail's children. So all the nodes here you can see are also visible as JLS. So what's up here, as I mentioned, it's a bit more complex graph than the one before. So yeah, of course, we have many more components over here. So the main thing you can see here is that this bridge over here is actually has enabled VLAN filtering. So that means we use, that's actually VLAN managed bridge. So each interface we can set to be an access interface. So for example, those two down here are access interfaces, and the one up here is a trunk interface. And we actually needed to do some hacky magic, because there is no such thing as ng bridge with VLAN support. So, but there is actually an ng VLAN node, but it doesn't really do bridging. So we had a bridge connected to ng VLAN, and for each VLAN hook, we connect another bridge, which does real bridging. So in order to do something like this, so I'll pause the experiment, do the necessary changes. So I'll just add another node to VLAN access interface 7. So when I resume the experiment, yeah, we have N22, node N22 appeared over here, connecting to a pipe, connecting to the bridge on VLAN 7. What that means is, yeah, I can just ping this PC in the same VLAN, and that's basically it. And actually, just to see that routing really works, and I'm not lying to you, I'm just gonna ping this, so you can see this this host over here. So really, we have, if I open the Wireshark window on ETH0, we see ping requests and replies going on VLAN 6, and actually, yeah, leaving the router 1 all the way to this host down here. So yeah, that's pretty much basic stuff. I can just disable this VLAN filtering, so you can see how it looks like without it. And yeah, you can see that the graph up here changed to have just one ng bridge. So this is it, with 3 links connected to it, and of course traffic no longer works because we have this PC3 has default route for IPv4 as 60.0.1.1, that's in VLAN 6. But I can actually just show you that everything works with IPv6. And yeah, this is without VLANs, so actually we have our router 1 has ETH0 interface set to the next hop for this PC, and the traffic goes as intended. So when you're done with the experiment, you can just terminate it. So experiment terminate, and yeah, it will kill all the jails. Just to show you, mount jails, there's nothing else here. The net graph is empty, and actually you don't have to terminate the experiment. You can just quit the GUI, it stays on the background, and we save states, save its state, so you can actually just attach it from another GUI or even CLI, so you can modify things in the terminal. So pretty basic stuff. Can I ask you if you have any questions here, or do you want me to show you something else while we're here in the demo? I'll just drink something.
I'll ask the predictable question, and have you considered adding firewall support to this, so that students can configure a firewall on a specific machine?
Do you mean specifically firewall node, or do you mean generally firewall? So
well,
because
just in general, I could imagine a lot of amusing exercises where you configure.
You don't have to imagine. There is actually a real example. I'll show you later. There's a repository with different types of examples for for different types of topologies. There is actually an example for firewall.
Yeah.
So actually, you can run IPFW to or PF or whatever
Yeah,
to.
well, that was going to be my question. Which one do you use?
In that case, it's IPFW, but
that's a fine
if
choice.
If you want something to run, you just send us a bug report or issue a request, and it will work. Actually, PF is just a couple of months old. We just needed to add a DevFS rule or something like that, and it worked on our examples. But if you want, you can just open the shell, configure the firewall. Or I haven't mentioned this, but there is actually a scripting. It's not language. It's actually a helper script where you can just write. Okay, it's called a Himage tool, in which you write. Basically, it opens the shell for that node. So you write Himage node PC1. Run this command, and you can write scripts and execute them normally. So run create this experiment, run PF whatever, ping, no ping, yes ping, whatever. And so our plan is to upgrade to TCL9. For example, export, import to or from other tools. I don't know, if you use Docker, you open up Docker compose a file in Immunes, and it shows up as a topology, or reverse. You export something from Immunes to Docker compose file. Custom mounts, extended annotations, multi-user presentation mode, lots of future plans, limited number of hours. Just a couple of notes here I wanted to mention. When you open up first thing, when you open up manual page for UnionFS, you're greeted with, this file system type is not yet fully supported. It will destroy your data, kill your mom, whatever. That's actually what the colleague was talking before. It's not that bad. Yeah, we're using it, and there are bugs, but it's usable. It's not unusable. It's a really useful, and it's a great feature of FreeBSD. So, but does anyone know when will it exit this phase of killing everything? That's a question for you guys. We have noticed slow shutdown of jails with VNet. Why? I'll just go through everything, so then you can answer and ask more questions. Why do jails shut down slower than they start? When will we have QEMU VMM support? When will we have MPLS on FreeBSD? NG Bridge with VLAN manage? Maybe in FreeBSD 15 something changes here. Is anyone working on front end? We want to have new UI built for sometimes in the future. We want you to help us. Of course, we suck at design. We suck at front end. I have questions. Do you see any features missing from other tools you would like to see in Immunes? Do you think it's suitable for ports, Immunes in ports? Maybe not this version. This is a beta version, but maybe sometimes in the future. Has everyone tried on other BSDs? What's impossible? What's possible on anything else? I haven't tried. I don't run anything besides FreeBSD, so I'm not sure what's possible, what's not. Okay, so I'll just leave the floor to you. So any other questions and answers from you, I'm happy to hear.
It's not a question, it's maybe I'll say a suggestion regarding features from the other tools. There is a company in Germany called Vector, and they called Vector. Okay. And they create a tool called Canoe. It's a simulation tool for, let's say, automotive networks in the cars. So, and they, well, quite mature, I'd say. And for example, one of those features which you could, let's say, think about, that network itself can be described in a specific format. And for example, this format, it's, let's say, generated. So it's prepared like by OEMs, and this format is given to tier 1 manufacturers, let's say, basically, and based on this generated network, we can, let's say, work on our own devices which are effectively connected to the simulated network. So, for example, your tool looks uncanny similar to what's available from Vector in that kind of simulation. And well, if it will ever be possible to import such network description from such proprietary tools, it would be extremely useful.
Okay, I'll just write this. So you said canoe? Canoe?
Yes, canoe. Yes, exactly.
Okay, so, okay, to do. Anyone else? Any notes about these things or questions? I have one more slide just to end this after this, so if we have time for a couple more questions.
So my GSOC student this summer worked on a prototype of like a Beehive VMM backend for a QEMU. And it still needs some work. Like I still haven't managed to get it to fully reproduce for myself, but it's probably far enough along as something that will eventually land. So it's kind of, you can consider that one a work in progress.
Any more questions?
Okay. Okay. Has anyone refreshed immunes.net and see that it worked?
I tried, it's still not working.
So
if that's all,
we're being sabotaged by Croatian power companies. Okay, so and last words for me. Yeah, help is always welcome. There's only 2 or 3 of us every Tuesday, so we don't have lots of resources. We have plenty of will, and we want you to help us by just using the tool, finding bugs. We like bugs. That means someone's using the tools. Feature requests, we want to hear them, issues, PRs, comments, whatever, on GitHub, mail, in person, over coffee, beer, whatever. This is our website, which will work. This is our repository, and this is the repository I was mentioning before, so immunes-examples, where you can find a dozen of different examples, which actually students use to so they don't have to run everything, create everything from scratch. There are a couple of scripts there, and yada yada. You can go download it and play if you would like. That's it for me. So thanks.
Thank you, Dennis. There's a small gift for you.
Oh, thank you.
Yeah. So,
this is blue.
I hope.
Okay.
Yeah. Enjoy.
I got 2.
You can do that at the end. If there are some things not clear at this time at the presentation, you can also raise your hand and we will take a look on how we can answer this. Okay, so there is a small website. Thanks Sven for hosting it. The packagebase.de domain, where you can find a link to my slides and also some additional resources. I would also like to mention that there now is a package-based chapter in the handbook, FreeBSD handbook, on package-base, which was created at the Berlin Hackathon this year. Also, I've put my presentation slides up on the schedule, so you can also download it there. So, what are we talking about today? We will just get into what is this package base about, and also how we or why should we use it, and then I'll get into the demonstration part, showing how to convert existing hosts to using package-base, to perform major upgrades, minor upgrades, and then at the end take a quick peek into how to build your own packages. There's also some stuff to keep in mind and maybe some upcoming things, because package-base is still in development and there are some parts that aren't quite finished yet. So what's all this package-based stuff about? Bapt has pitched the idea of the FreeBSD base system, packaging it into smaller packages at the BSDCon 2015 in Ottawa. So 10 years later, here we are now, still tinkering on it, but I would say it mostly works. What package-base should allow us to do is to create minimal installations, to throw everything out of the system you don't actually need, them to you. Do I have some slide for that? Yeah. So we will go ahead, create a boot environment, and then bsdtl create 42p3, and then pkg, or I should modify the configuration file first. Package basify will create a package configuration file in usr local etc pkg repos, and then freebsd-base.conf. So as you can see, I have modified this in the package basify Lua script to create a custom URL here, just so this demonstration is working when probably not connected to the internet or whatever, so everything runs smooth here. So we will just change this URL line to base release 2, which it would normally look like, as you can see above here. Let's save this. This is the state where your system should be after package basifying it. So we just run pkg update and then pkg upgrade, and it will give us a list of all the FreeBSD packages which will be upgraded to the P5 patch level. Let's do this. Okay. Speaking of patch level or base release strings, this quite took me some time when first experiencing package base and getting into all of this. The string of the package FreeBSD base configuration uses the ABI and the version minor variable to then get the equivalent version out of as package-based packets. So if we're looking at an example, FreeBSD 14 ABI with base release 3 will be FreeBSD 14.3, where 14 is of course the major version and 3 is the minor version. So some examples, 14.2 would be base release 2, 14.3 would be base release 3. The current or alpha releases are using base latest, as well as the FreeBSD 16 current, which also uses base latest. So you can tweak these values to your likings. Let's take a look. Our system is upgraded. FreeBSD version -KRU. We should probably restart now to get every so that every running library gets the new libraries get used. So let's go ahead and do that. I might as well convert this to Sylvia, but this is just my setup now, so we will have to be okay with that. Okay, so now after upgrading FreeBSD version, we're running the P5 release on kernel, runtime, and userland. So let's take a look at minor version upgrades. I think I have a slide there. I will now show this with using a boot environment to upgrade the system in the boot environment and then reboot. You could probably also use pkg update upgrade on your running system, which probably works, but this might be the safer way to upgrade your system. So let's create a boot environment, or shall we edit the config file first? Use local etc pkg repos. Change the release string to base release 3. Save. Create a boot environment, bctl create 43 p2. We will mount this boot environment, so I will create a folder for it. And mount it, bctl mount the boot environment name and where it should be mounted. So now our boot environment is mounted in mount 14.3p2, and we can now go ahead and use pkg with the -r for root directory, or probably also could use -c for change root. Use this directory and update. Now it gives us the error that the current userland is not matching. We will ignore that because we know we would like to update, and then use the upgrade to then install all these 14.3 packages. 40.3 P3 just came out. I have built these locally on P2, so we will probably need to use that for now. But P3 probably works too. Okay. If you're not running a ZFS system, you might not have the option to use boot environments here. As already stated, minor version upgrades work or work directly as probably like the patch level update. But I just wanted to show that this might be the safer way if you're allowed to do so. Okay, so let's show the version. And because we haven't enabled the boot environment or rebooted yet, we will bctl activate -t for temporary, and then 14.3 P2. So if we reboot and something happens which shouldn't happen, or something breaks, we can just reboot again to get to our old boot environment, because this is just activated temporarily. Let's take a look how, okay, we can now log in back, so. FreeBSD version. So now we're running FreeBSD 14.3. Way. We can now probably look for further package updates or run our system to our likings. There are none, so just continue. So let's activate this boot environment so, to come as the default boot environment. bctl, first list, and then activate no-t, this time 14.3 P2. And if someone's not familiar with boot environments, the active column shows that this is the boot environment we're using now, and for now. And this is the reboot boot environment, which should have changed by now. So this is now and reboot. Okay, so let's get into the major upgrades. We will just do it like before, change the configuration file. To base latest, save it, and then we will create also a boot environment for security reasons. And also mount that. Okay, boot directory is mounted. As we can see here, this is our whole system. So for major release upgrades at this time for the 15 Alpha 3, there is a major issue where if you're using package base or upgrade by using package base, in the process it removes PKG while upgrading through PKG, which is not ideal. So we can at this time get around it by locking PKG. So I will go ahead and pkg-r mount 15 lock PKG. And this time we're using using the environment variable to override the ABI. So env ABI equals FreeBSD15, AMD64, because this is an AMD64 system. And then pkg-r for our root dir mount 15 update, and this time I will only update the package base or the packages out of the base repo. So -r for repository, FreeBSD-base. It again asks if we are using that OS version. Let's go ahead and do that. And also upgrade. So at this stage, there would be some packages to be removed, pkg, which now it isn't. Yeah, there's this question.
So once you're on 15, can you run a package -o blah 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 install -g /star to make sure that you caught everything? Because if you just upgrade, I think it will not match everything because some of the new ones aren't pulled in.
Great, yeah, that's actually another problem yet, that new packages that have been created won't be installed by default. It will just upgrade existing ones. I hope this will get fixed until release, probably.
It will be kind of fixed by the packages going forward. So if you install the full set, it's basically a meta package depending on all the other packages. And that means that going forward, as long as this meta package is installed, everything will be installed.
Okay.
But if something is removed, it also doesn't get uninstalled. So you can end up with an old package because there is no newer package of that same name to upgrade to.
Yeah, okay, thank you. So now we've upgraded our boot environment, and I will go ahead and unlock pkg to then upgrade our packages, because otherwise there might be some broken libraries. So unlock pkg, use the almost the same command, but now we will use the change root to actually use the local pkg version in the, or upgrade the upgrade the pkg version in the boot environment. So we will update, and as we can see, pkg 231 will be updated. Go ahead and do that. And also I have installed some basic packages like vim, htop, and tmux. So we will also go ahead and upgrade them, which shouldn't take that long. So maybe come back in a minute. Yeah, if you're not using a boot environment, I have seen seg faults, I have seen some other errors, so I hope most of this stuff will get fixed until 15 release comes around. But most that you would need to know for this is using the ABI environment variable to override the ABI.
It's
Okay, use the -o in PKG. Okay, thank you. Okay, you can also specify OS version in PKG. Okay, we're done. So let's bctl activate a -t for temporary 15, and then go ahead, reboot or shut down -r now. So we should get to a freshly upgraded 15 Alpha 3 release. I will then just take a brief look at how to build your own packages, but we will not do this here because running on this laptop, the build word will take about 2 hours, which we don't have in this talk. So let's take a look. FreeBSD version. I can't type anymore. This is 15-0 Alpha 3. And then bctl list. Let's activate this as our default. And yeah, we're probably good to go. So we can check PKG --version is running 2.3.1 as we are expecting. Okay, so why should you build your own packages? You don't have to. If you're running just few machines, you can just use the upstream PKG repositories. But especially if you're running multiple machines in a local network, you can use the speed over your local network. And also, if you're probably connected to, or your local network isn't directly connected to the internet, you now have the option to build the packages internet connected and copy them to another server in this not internet connected network and publish it by using some web server like Nginx. So then you can upgrade all your hosts in that network using these build packages. How do we do that? Let's switch to my builder machine. There probably are different ways, but there should be some way to use it with, okay, 10 minutes remaining. There should be some way to use putrea to build these packages, but I haven't quite figured it out. So let's just show, I will just show you the way that worked for me. I have cloned the source tree in user source, and then I've been using git. Let's show the branches to switch to the desired branch I would like to build, like Relang 14.2, 14.3, or stable 15 in this case. I then use make-j whatever course you have available, build word. After that, or probably with connect that, make build kernel, and make packages. There's also a build path for make update packages. I haven't quite used that one because most of the time I'm just building them from do a full build. So what happens after that's done? There will be a folder user object user source repo, and there will be both of your, or all of your ABI directories, where there then will be your release folders. To be compatible to the official repos, I've been using some symlinks to change base release 2, base release 3, and copy them to the other machine where we would like to publish them with using Nginx. So let's see the Nginx configuration, which just uses, in this case, it's an HTTP server for simpler setup, which uses the location FreeBSD 14 in my case, to point to the directory we've seen just recently. And I've also enabled AutoInix, so we can take a look at it in a browser. So after starting Nginx, this we would need to change our repository. As you have seen, the usual local etc pkg repos. We just changed the URL, and in this case, because it's HTTP, we are just using HTTP and comment out the mirror type, signature type, fingerprints, which is just to get this demo working easily and not have to deal with signing packages, which you can do, but for that simple demonstration, I haven't done it. Okay, 5 more minutes. I think I'm almost running out of time. Let's get back to our presentation slides. Things to keep in mind. There are still some things work in progress, as you might have seen by now. If you do have the option, remember to create boot environments so you don't destroy your running system. Also, it's not a very bad idea to go and force remove all packages after creating or moving to package base. Yeah, because you're then left with the system without a system, basically. If you use the force flag, of course. And also, when experimenting or trying things out, probably back up your stuff so nothing gets lost. I hope there will be some or a lot of stuff fixed when FreeBSD 15 release comes. So let's see what probably comes next. We should be working on package base, and probably also, that's my call for you. Please test it, use it, try it out. There is a lot of stuff working pretty well, but yeah, sure, there's also a little bit of stuff not finished yet. As I've already said, Mark J is working on a FreeBSD update wrapper to use package base by using the FreeBSD update script. And Ivy is also working on package based sets, where you can just install the minimal set, which will be FreeBSD-set-minimal, which is a meta package, as already stated before. Yeah, also some thing that might be interesting is pkg delete-r for repository. So we can only delete packages from our ports repository or whatever, which doesn't exist yet. And also, I'm missing a prompt to reboot my system like FreeBSD update does if there are any significant changes to the kernel packages. Yeah, questions?
The package delete one can be built out of package query, you query for everything with not category base and pipe it into package delete.
Yeah, probably that's also an option, yeah.
Can you go back to the sets, please?
Yeah.
The previous sets. I was wondering what's the process for package base compared to ports? Like, do you have proper dependencies between packages, or do you just try to test sets for now? And do you have any tools to ensure that when you install an arbitrary subset of package base, you're going to end up with something that works?
I haven't quite got myself into testing these package sets, so I'm not sure if I can answer your question.
Yeah, but basically, for instance, you've got some libraries and you've got ldconfig output and stuff like that. And you should be able to say, okay, this specific package will need this library, so I should write a dependency. It means that, as we have done for ports forever, in basically every BSD, you will have at some point to have some actual dependency information that's correct. Is there anyone working on tools to make sure that happens?
Sure how to answer that.
I don't know. If you don't know of anything, there's probably no tools yet, and what should probably work might be sets if they've been sufficiently tested. But in my opinion, at some point, you need to have some mechanized tests to be able to go further.
Yeah, probably. Yeah, thank you.
I've heard package sets referred to as package upsets because someone's going to always be upset about it. But anyways, if you want us to test this, do you recommend that we test 15, like the latest alpha, and just run that? Or would it be valuable? Would it not be valuable to test the older ones because you can't really do anything about it now?
Yeah, I think it would be a great idea to test the 15 stuff because that's what they're actually working on, yeah. Yeah, there's a question back there.
So my understanding is that on 14th, package base is optional. I mean, voluntarily you can opt for it. But how much merging from current happens from the work that is done for 15 and the FreeBSD current to in the scope of package base? What lands on 14?
Sorry, I think I haven't quite heard the question.
My question basically means how much work that is done on 15 and current is merged from current to state branch 14th.
Unfortunately, I think there will not. I'm not too sure about that. I cannot quite answer this definitely, but I think there won't be that many changes getting into back into 14, but maybe by release 4 or 5, we might have some solutions in 14 also. At the mailing list there was a comment from Ivy that package base isn't, or upgrading from 14 to 15 with package base is not officially supported because package base is not or was just introduced in 14, but I think we will get around to get it working. So hopefully. Okay. Any more questions?
I think we're out of time. Yeah. So for any other additional questions during the break. So thank you for the presentation.
Thank you very much.
Enjoy.
Good. Well, I started with this. This was my first access point. Yeah. And then I was a long time on SAMS, FreeBSD, drifted off to Apple after a while, and then in 2018, someone came and wanted to do FreeBSD on a phone and asked me, you know networking, don't you want to do Wi-Fi? The project didn't last very long, not the Wi-Fi part, but the phone part. But I ended up picking up MMCCam and SDIO for Broadcom, and I'll talk a bit more about that later. And so we are here today. What you'll get about from this is Linux KPI and Wi-Fi. Why? Why did I go that route? Does it work? Well, some of you hopefully know by now. What was involved? What I thought wireless development would be, what I wanted to do, what I ended up doing, and maybe a bit about all the stuff that is not coding, and in the end, where we are now, what I'd like to have in the future, what we need to do still, what's going to happen. So it was April 2020, and I was faced with the decision, how do I update Intel Wi-Fi to something modern? And one thing I didn't want to do is maintain drivers, really. And that came out of multiple decisions. I have to say up front, I had a very good chat last night with Stefan from OpenBSD for the first time, and that helped a lot. But when I look back then, the problem with our drivers in FreeBSD that came via OpenBSD was like, I had no references to upstream versions, to the Linux versions. All the names have changed because they are called IWN, IWM, IWX. Tracking that back to Linux was just a pain. It's the extra indirection you don't know, and I had no idea how to maintain that, and I didn't really want to because new chipsets, new versions. I know Mark Johnson at some point did a 1-week full-time job to bring a new chipset in, and that sounded too painful. Before I prepared slides, I watched an old EuroBSDCon talk, and if you look at the end, 32 minutes in, at the questions, Warner Losh basically spells it out and says, there are permissively licensed drivers in Linux. There was a bit of confusion about the KPIs and the abstractions, but he said, you can just bring them over. The answer from OpenBSD at that point was, we do them one by one, individually. We don't do Linux KPI. It's probably a lot more work. So we'll see about that. Now our problem is firmware is a black box. So vendors know what's going on. If you have no official support from vendors, like Sam back then was at Aferos, Adrian was for a year at Aferos, they had inside information, they could look at stuff. We can't at the moment. And then the third thing was, the size of drivers has become huge, and I'll have numbers later. So Linux KPI seemed to work for DRM, and I was the only one working on Wi-Fi at that point and said, okay, I'll do the same, I'll give it a try. And if you ask me now, does it work? I would say yes. Your experience might vary still, but more drivers may sound like more problems, but we also had the thing that more drivers solved some problems, like when I did Realtek, the first one, it solved 2 problems for Intel, just because code was used differently and things got sorted. So I've got 3 tables here. On the left, it's native drivers, both wired and Wi-Fi, and it's lines of code, or thousands of lines of code in this case. You've got the Linux KPI drivers in the middle, and then on the other side, it's the 802.11 stack parts. So there's a few things in here. You will see the driver size has become on the order of 10G or faster wired NIC drivers these days, and that's a lot of work to maintain. I haven't added up the numbers. Realtek is a bit special because they have tables inside, and so I took them out of the numbers on the right side. But the overall thing is, I didn't want to maintain more than 500,000 lines of code, or even take them from Linux, completely rewrite them, and then make them usable. The other thing you might notice is if you look at IWM and IWX, the native drivers on the left side, and you look at IWL Wi-Fi, this is 40,000 lines of code. Some of that is common to 120,000 lines of code. So you can see there is a lot more going on in the native driver from Intel compared to what our FreeBSD native drivers are doing. The last thing you can see is if you look on the right side, the Linux KPI 802.11 bits are like 18,000 lines of code, and that is still less than IWX. So the longer term, the more drivers we do, Linux KPI seems to work out in terms of work. I'll say something about native drivers as well, because we do have IWX, which came in the meantime because I guess part IWL Wi-Fi took very long. And a lot of people ask for it, I think, over time. I'm happy someone did it, because we have a driver to compare to, fairly modern still. If you want to look at how data paths go different, if you want to look at the different size of like 20K to 120K, what's going on, it's a lot easier. So for comparing things and for going forward, for developing native stack work, this is going to help. So how does wireless development look like, as in like, what do I want to do, what have I done, and what's the non-code parts? Why did it take 5 years? Fair question. We'll see. So what I wanted to do was fairly easy back then. You do the net 802.11 or 802.11 code, and you do the drivers. Sounds simple. This is how I felt after a while doing it. You started doing station code, and the first thing people, after it starts working, along with the drivers, they want throughput. So you start looking at crypto. People asking about suspend resume, their reliability things, because they still have firmware crashes. You help them, you solve bugs. I've been asked about new standard support 3 times. I've been asked about new drivers by now 2 times today. It's just more, and you can't do it all together in one go. But somehow you need to go there. So why did it take 5 years? I've subtitled this all the things I had not planned to do. The first thing initially was Linux KPI and cleanup. When I started porting the drivers, I was faced with the problem that bringing in way more networking code from Linux conflicted with what we have in Linux KPI. The original bits were shortcut, so struct net device in Linux was a one-to-one mapping to struct ifnet, and the Linux code used elsewhere, like in the InfiniBand stack, was changed to use the native ifnet code. Cleaning that up, cleaning things like this up, took time. Back then, DRM, it's still out of tree for us today, but they had a lot of Linux KPI bits still externally. They weren't in our tree, they were sitting there. Some of them were GPL. And that got better over time as this got merged into the tree and the conflicts were gone. But you add new code, you have conflicts with what is in DRM. People will like improvements on Wi-Fi, but they really don't like breaking your graphics. So you have no choice but sorting those things out. The next problem was semi-native drivers. We do have vendor drivers in the tree that are native BSD drivers, or so you think. And you will find they still use tiny little bits of Linux KPI, header files, and you start changing structs, you start changing PCI code, and suddenly these drivers break. Another thing to sort. And I think the last bit that delayed stuff was doing driver updates while the Linux network stack was under high churn. They were implementing 11BE. So their structures changed, their internals changed, and became right in that moment. And if you think about that, and if you've been in Martin's talk from NetBSD before, it sounds like we've been facing similar patterns in that regard, because when they started, we were stable, solid, nothing really happened much in FreeBSD Wi-Fi. And I came along and a lot of things changed and they were facing the same problem. So we are building a chain here. If you want to develop drivers and don't want to dedicate an entire laptop and gear to it, Beehive is a fantastic platform. You do PCI pass-through, you do all your development inside Beehive. If something crashes, you still keep working. But IWL Wi-Fi didn't work in Beehive initially. And I'm pretty sure there was a second fix we had, John, but I couldn't find it anymore. It was something with the bars that were non-standard, I think. And that fix, like being able to start working inside the virtual environment, helped a lot for driver development and then going forward. We had the same problem fixed 2 days ago, thanks to John's help, with PCI function level reset and the media text. They announce it, and if you do it, the card goes out for lunch and never comes back until you reboot. And that means you reboot your device and reboot your device and reboot your device, and that doesn't scale. Then there was a problem with DMA, bus DMA versus malloc versus ARM64 versus Realtek. Intel isn't so much affected by it because they do 36-bit DMA for the old cards and 48-bit for the new, if I remember correctly, so you never see it. But Realtek only does 32-bit DMA still, and so it's a lot more visible there. And the problem was that they need 4 consecutive pages already when they load their firmware. And I do a lot of development on ARM64, and bus DMA on FreeBSD will not give me 4 consecutive bounce pages. And analyzing that, we found that the Linux KPI allocations weren't quite doing the right thing, didn't give you contiguous memory when you need it for the single segment DMAs. So we started fixing malloc in FreeBSD, or improving malloc in FreeBSD so that config malloc would work with free. Fixed Linux KPI allocations completely, which hopefully helped DRM a bit as well. But the ARM64 problem still remains for me, and I wanted to prep him this afternoon, but I didn't get a chance yet. Then you do firmware and licenses for drivers, and some of this has non-standard licenses, so you run it by core, and when you come up with the 3rd or 4th driver, someone asks, how much more firmware do you want to have? And I looked at it and summed it up, and I said, it's going to be more than 100 megabyte in total of Wi-Fi firmware that we're going to get into source. And they said, well, put them in ports, please, and don't import them into SourceGit anymore, so no big blobs in SourceGit. So I had to learn ports. I had to factor that stuff out. By the time I had the firmware in ports, someone came and said, we should split this up into flavors because I don't need all the IWL Wi-Fi installed on my device. So did that as well, and there's a lot of help thanks to Joe from the foundation who did the test runs and everything for me and helped to get me those in. And then you have the problem. You have firmware outside of the tree, but you need it. And thankfully, Manu eventually wrote fwget, at least the first iteration, which I then extended, extracted all the IDs and stuff automatically by scripts from drivers to write the tables for firmware get for the ports bit. Warner at around that time also implemented plain firmware file loading, so we didn't have to compile the firmware into kernel modules anymore. And both of those things helped massively to ease the situation. And the other problem is, of course, if you have a laptop, you install FreeBSD on it, and the only thing you have is Wi-Fi, you need the firmware to even get on the Wi-Fi to get to the network to install. And with Colin becoming lead release engineer, that was finally possible to sort that out, get the firmware bits onto the release media. And then we also fixed BSD install, so at the end of your installation, it would install the firmware into your new system. And you could just reboot and have Wi-Fi again. It's the chicken and egg problem that's going down there. Vendor imports was another thing that was like 6 or 7 months going on over time. And the reason was I never done vendor imports before. I had committed the drivers. Initially, I updated them inside FreeBSD and then wanted to start vendor imports because it started to feel like we're going to do this regularly compared to what was done before, like the driver was imported once into BSD from OpenBSD after the conversion and then fixed along the lines. And we wanted to do the historic commits backwards, like with the vendor imports, to fix the history. And to sort that out, just blocked things for months and until it was sorted. And then I could finally do the next driver imports and everything that was hanging behind that. But these things just go on and on sometimes, and the switching, yeah, the egg was funny, and I forgot to put the commit messages in, and so the first thing I got was like, you've just done vendor imports for I don't know what actually, because they don't do anything. They don't bring any new code. And then it was real life and a bit of not so much availability. If your roof over your house looks like this, I think you have other things to sort out than Wi-Fi drivers. So that contributed to quite a few months of me not working full time. And then came the point where we were like, okay, this thing is associating, we're getting on, but it constantly crashes. And if you look at the YouTube description for Patrick's recording from now 6 years ago, it says the NET8211 stack wasn't written to handle full MAC. Full MAC is a separate problem, but even the modern firmware-based cards, our NET8211 stack isn't up for. That means we were building up state, you're telling the firmware, do this, and NET8211 under us would just say, now go to some other AP, or even go to the same AP and start the entire authentication and association again, and completely forget about what we've just done. And firmware really doesn't like if you build up state and then leave it hanging there and start from scratch. So this is what held us up a very long time figuring that out, along with logging, which was inconsistent, and the fact that we can't sleep with our big IC lock. And we unlock also opened up us to races, and this is nothing new. This is something that is still in IWM. This is in IWN. This is basically all the firmware-based drivers that we've ever imported from OpenBSD that people would unlock and relock. And the fact that we are pushing it more, and the fact that the code paths are a bit longer now through Linux KPI, through the Linux driver, likely just made it more visible. And so there is just tech debt in net8211 that needs to be sorted. And then things started to work, but not for some of our users. So my setup is my reference. I can test with what I have in the house. I can test with what I can reach in the neighborhood. But I can test in your homes. I can't test with your machine. I can't test with your usage patterns. So I've been sitting there trying to reproduce problems for days that other people had in 5 seconds. And that is a problem with remote debugging for these things. And that's just hard. And sometimes you have to punt and move on. And sometimes you have to try harder. And sometimes someone will come and give you the clue. I've just done this and it happened. And you'll have a reproducer. And with that, you can look at it. And usually it's then fixed within very short time. Well, and for some of the things like Intel, not so much, but Realtek maybe. Linux drivers also have their problems. I mean, it's software, we know software. No software is perfect. And there is null pointer dereferences in there that you hit. There's all kinds of things. So you debug driver internals after all, but very little, I have to say. Linux KPI is not 100% Linux because we map to native calls. So behavior might be slightly different, and that might lead to different results. They have the nice green side of having a hardware team. They have the documentations because basically all Linux Wi-Fi drivers come out of the companies that produce the chips. More or less, they'll get through hands of other Linux committers to clean them up sometimes. But it's the companies behind them, which we don't have anymore. And yeah, we have to live with it somehow at the moment. And then another thing that probably takes time is Wi-Fi in the 90s was different. If you knew the card at the beginning of the presentation, and if you look at what a card is doing now, that's two different worlds. And if you wonder what the talk jockey is, I was in Cambridge and I used to say the Wi-Fi standard, the length of the table of contents has the size of has the size of pages of a PhD dissertation. It's the table of contents that has the amount of pages of a PhD dissertation. So the standard comes after. Yeah, there's blockers, which people might have noticed practically in the last weeks. I think I'm sitting on driver updates now for 8 or 10 weeks in total. DRM is still outside the tree. I had changes to DRM, which were thankfully committed to DRM. People were on vacation over summer. No one tagged the tree. No one updated the ports. And I had the option, either I get my stuff in or I break DRM just before we branch a release time. And so I had to wait. Those conflicts were thankfully happily solved by Dumpwell after he came back. And the immediate thing that happened is I broke NVIDIA twice with 2 changes. It's out of tree. It's semi-native driver, so they have native PCI and they put the Linux KPI PCI on top, and that's not been updated in like 3 years, and so wasn't just up to scratch for that anymore, and things went kaboom. Thankfully, the one fixed both problems, but you end up reading graphics code and not Wi-Fi code and trying to produce the fix. And then you get it all working, people get 11n NAC in your hands, and then someone comes and says, I'm still using TKIP. I need TKIP. You hadn't implemented TKIP. If you don't know, that's encryption bit for Wi-Fi deprecated in 2012. You are laughing. If you're not on the conference network in here, all the other networks here use TKIP. So, yeah, it gave me a good reason to test TKIP out of my house. I had real trouble to actually find equipment to still test it against. And well, if you're doing Wi-Fi development, and all these, to everyone I talk, the answer is you start with a laptop or something and you put a card in, and every week you open your laptop and you switch the cards, and the cards and the pigtails, the connectors really don't like being changed more than 2 or 3 times, and you don't want to open your laptop all the time. My setup for a long time, especially if I was on the road, was I had a laptop running Beehive with IWL Wi-Fi in it, connected to a router IP, loop back on Ethernet back into that laptop, and you could do native testing on that laptop through an IP, and that's all you need, in theory. In practice, you end up with cards. You end up with Wi-Fi dongles, and you don't want to switch them every day, so you need to start thinking about scaling these. I know Adrian has a PC card device still in a laptop for external to change the cards on, if I got him right, but I don't have PC card anymore, sorry. So I had 2 APU devices which have 2 mini PCI slots, which I started with, got me 4 cards, but they were still in a case. So I took them out of a case on a PCI slot on these really cheap USB cable connected PCI slots. And then I had can't remember what they are called, whatever. Multiplier cards, basically, they have a PCI switch on board and you get 4 mini PCI slots out of them, and they are easy to lift in and out of the PCI slots. But still, it gives you only so much to test, and the APUs really don't scale anymore these days. But it was good to start with what was in the house, kind of. You get more laptops for the road eventually, but not so much for stationary. So in 23, I started building it out. And I had a honeycomb machine, which you see on the lower picture on the lower end, and I found an old 19-inch server case, took everything out. The 4 drive bays in the front neatly fit 4-slot PCI cards, and I put those on extenders. So I have now 3 PCI switches in a chain, but I can put up to 64 cards into that case, and it's more than half or almost 3/4 populated these days, but I'm still swapping them sometimes. The front top of the case is easy liftable, so you can just take it off, take a PCI card with 4 cards on out, and swap them around. There's another cable going into that case from the back, which is just for the fans to get the heat out. But you want to put those cards really into D3 mode on boot and only selectively enable them as you need them. And once we'll have pass-through on ARM for Beehive, it'll be a lot more usable because I can I can work on 4 cards at a time or 6 cards at a time. The USB setup from the mining, if you want to see the cards itself, Tom has a blog post. When he worked on IWX last year, he found the same solution basically, but he stayed with 1 PCI board with 4 slots, and that was enough. Don't mix those PCI things, don't mix those USB things. the adapters from different vendors have different pinouts, and they transport PCI signals. And you'll also find that there's not enough wires in those cables to transport all signals. So depending on what you do, you get different signals at the end, and that is a pain because I think the Aferos cards and the MediaTek cards, both depending on which version you take, one or the other doesn't come out of reset, even with the FLR fix. I hope someone will build cheap multi-slot PCI boards with OcuLink connections or something, and I can do this right at some point. You start collecting access points at some point because you want to test against other gear. I have now 7 in the house, I think, and I have OpenWRT either in Beehive through those cards or on other commodity hardware. And when you're on the road, you need a monitor station these days. And the reason is fairly simple. If you can't control your IP and dump on it, you can do TCP dump or Wireshark on your local card, but you will not see what the firmware is doing anymore. The firmware is sending frames out without you knowing. So in order to see what's really going on, you need a third party that sits outside of your communication. And I, for traveling, ended up repurposing a Raspberry Pi 5 with an NVMe slot, which has an adapter to a Wi-Fi card. And in the second generation, as people have found yesterday, I put antennas on the outside. The initial idea was it has the Broadcom on board as well, so in theory, I could use it as an AP as well at the same time. But it is still running Linux at this point. We don't have Raspberry Pi 5 support yet, but I hope this will change over time. And then I got a Framework 16 because you can get the extra 2 NVMe slots in the back. And if you think about that, you have 3 Wi-Fi cards, which is, you have your station, you have your access point, and you have your monitor node, all in one computer. So you take your computer out, and you have a full, complete test setup with you in theory. It was wishful thinking at that point because the adapters went higher and higher, and in the end, you had a fraction of a millimeter that you didn't want to squash in the case anymore. So I have last week finally managed to do at least one of them for an OcuLink connection. And so I have external NVMe cases now that I can swap back and swap the cards a lot more easily, but you can do more than one card in the laptop and do development and debugging really easily. So I'll go back one slide for a second. If you are thinking about how do I actually write code, how do I debug stuff, running TCP dump, Wireshark, and other things, I've left those completely out of my presentation. Tom is currently writing a series of articles for the FreeBSD journal, and I encourage you to read those instead. And you'll learn all the bits there. There is certainly a few places where we can get extra hands, very easy projects to do, where you don't need all the setup and gear to work on. So if you're interested in a bit of Wi-Fi, read the articles, come back to us, talk to us, and then you can help us filling the next gaps here. So where are we now? Adrian has done 11AC for RTWN for the USB dongles for the modern old ones. He never merged it, so it ships with FreeBSD 15 as it comes out now. IWL Wi-Fi shipped 11 and NAC support in 14.3 already for the modern chipsets. And if people ask me why only for the modern chipsets, the answer is the older generations have 3,500 lines of code of GPL only management in there for rate control and everything, and I have stayed away from them. I initially thought we can just do it, but if you ask me at this point, the time it takes to hook them up properly and put them in a port or something, or rewrite them completely. A modern Intel card is between, I would say, 8 and 15 euros, depending where you buy it and how fast you want it. You can get a lot of cards in the meantime for the time you need to spend to hook that up. So I'm punting on this unless someone wants to do it. I had one user who looked at it. We made it compile, but the problem is you need to drive the rate control from net8311 in that case. If you think about throughput, I don't have a video here, and I wanted to have the gigabits standing there everywhere, but after my last rebase of the tree, something had changed. I've not had time to debug it. So I'll leave you with where I've been at some point. This is UDP, so we are doing 850, 900 megabits there, and TCP is like 900 and 700, and I should add a footnote here. The reverse path is currently done with -R in iPerf, and I've recently learned that apparently there is a difference if you just switch server and client sides compared to if you do -R. -R seems to have a pessimization. I don't know why. The academics say so. So I'll rerun them at some point, maybe in a month, when everything is sorted and Mark can do a new video for everyone, and we'll see what's going. Then drivers continued. What else is supported? Realtek, the 88 version is in, the 89 version is in. Most of that works. 89 is still a bit bumpy for some people. They do AVG. They need a bit more Linux KPI support, which is filling a few functions for crypto and offloading stuff that just very state different ways than the Intel cards. And if someone's doing that, if not, I'll do it at some point in the next weeks, hopefully, and then they'll do 11 and NAC as well. MediaTek will hopefully get more traction now that I can work in Beehive and don't have to dedicate a laptop to it and reboot that constantly, walk to the laptop and everything. And then, given I've been asked about Qualcomm today, we have the Aferos 10, 11, and 12 drivers in the tree. I don't know if I updated them with the last round, but I certainly can do that. They compiled. They need to go through bring up, and 11 and 12 need the MHI framework to download the firmware, which comes from the modem side of things from Qualcomm. I don't know why they changed it, but certainly extra complications, and you can't just import it. It's GPL code for us, but I've been told OpenBSD has sorted that problem. So if you look on the market at the moment for USB dongles, there are two versions, RTW88 or MediaTek. If you look under the hood, basically, I have USB for RTW88 in brokers, but the problem is Linux KPI versus native USB. So Linux KPI is included in our native USB stack. For USB, I don't know, they've done it, I think Luigi done it 15 years ago like this, and no one touched it since. So it needs cleanup, and it needs to be divorced, so to say, because we need a lot more USB these days, and we run into conflicts. And I have a very ugly solution for that, but I didn't want to put that in the tree, especially not just before the release, so we'll have to do that. And SDIO, I'm scanning at this point, and now I need to do the extra hooks too. That some people asked me when I did SDIO back then, you're missing the thing to actually switch modes to go fast and do big block transfers, and I'm like, yeah, I would rather make sure this thing starts working first before I think about speed. And once that has happened, I think we'll have an SDIO driver in the tree as well. And that gets me to Broadcom. The question comes up twice or thrice a year still, because we don't have the driver. There have been a few people who tried to port BMFW from either Open or NetBSD. Everyone has gone away. I have no contacts with any of them anymore. I think eventually they just gave up. But there is someone doing the PinePhone at the moment who has an interest, and there is someone who doesn't even want to do Wi-Fi on the Broadcom chipsets who started emailing me recently. So we'll see if that's going to happen. And the SDIO will mostly benefit from what's done for real text, so it'll, apart from a handful of cases that where Linux goes down directly to MMC will just work, but the main problem will be we need the abstraction for config 802.11, which is you get a firmware message back, but we expect beacons, information elements, and everything in that 802.11, and given it's the only driver or only relevant driver, I'm not sure who's gonna do the work. Or I think once scanning works, there's going to be enough tractions to just finish it, and we'll finally have it. I've looked for numbers, like where did things go? It was about 1,125 commits in total in the last years. I say roughly because numbers keep changing over the last days still, and I've committed a few things from other people. The interesting thing is a lot of things have been outside wireless, and that comes from the cleanup that had to be done initially. And the other thing that you look at, Linux KPI wireless and Linux KPI is basically on par in terms of how often did files get touched with commits. So it's about a 50% work in generic Linux KPI code that is PCI, infrastructure, all these things, and about 50% of wireless. And the next thing that needs to be done is Net 802.11, and we'll get to that. Problem reports is basically neglectable, but the one thing I wanted to point out is we have a hierarchy in the bug database where you can look. We have tracking PRs in between, and we track them all since I started Linux KPI drivers. So if you go to the PR, say show dependency tree, you see all the Linux KPI drivers, and you can click on show results, and you see all the closed ones. So if you have a problem, it's really easy to figure out, is this known or not? The next thing is once the NVIDIA problem is, the port is updated, I have driver updates waiting. I'll have to battle with release engineering, I think, at this point to get them in, but we'll see. And then Linux KPI needs a bit of cleanup. It already knows about 11AX and 11B. The structures are there, the defines are there. We just need to drive it at some point. And for that, Net 802.11 will get the tech debt addressed. And then maybe migrate some of the Linux KPI things into Net 802.11. And we've got kind of permission to break 15 in between for Wi-Fi, but we should try to do it as little as possible. Adrian is doing WPA3 in crypto work to get us there because we'll need it for 11AX. And then, yeah, 11AX, 11B by the end of the year, I assume we'll have 11BN showing up in the world somewhere. So we'll have the next generation. And if you would ask me what I want, there's more things to do. Some of that could be done by others, like monitor mode, for example, would be really nice to have, and would be a really nice project if someone wants to start wireless. And if I would have time, I would like to ask you what you would like to have now, but maybe we can do that in a minute. One thing I will point out here, what I would love to have is, it worked for Wired in that vendor drivers that we have these days is companies are producing the same driver basically for Linux and FreeBSD. And if we show up at some point having done the catch-up thing, we use their drivers, I would wonder if we can get the abstraction sorted so that we can have a native data path at least for MBUFs at some point, split them up like library functions kind of, and then see, like we've done for Wired, but we'll see. And yeah, in summary, I think Linux KPI works. It'll work a lot better once Net 802.11 gets sorted now. Wi-Fi development is, as you have seen, not just Wi-Fi development, but unfortunately a lot of things around it, and there's more to come. And my wife would know I'll sing eastbound and down in those cases. We're going to do what they say can be done, and we've got a long way to go in a short time to get there. And that's basically the summary. I'm eastbound, and I'll be on holiday from Monday on. So thank you, everyone. Thank all the users who've helped, who've answered, who've tested, who've debugged, who sent feedback, especially to the few that submitted patches to fix RTW88 and other stuff. Thank you, I should say, for George, who sent me a laptop in the very beginning. Martin Höhne from Mini PCI-Bis, who keeps sending me cards at times when I ask. And there's been a lot of people that help sorting out all the things around, sorting out Wi-Fi. I can't list them all. Thank you, everyone. And my thanks go to the foundation. And as I keep saying, you should say thank you to the foundation, but you should send your bug reports to me. Good. I don't know if I can go over. Okay, I'll take one question up there. The answer is it'll be ready when it'll be ready. I hope sooner than later. As I said, having the ability to just put it in a beehive and do other things with hardware at the same time really helps, so I hope it'll speed things up now. No. At some point in 15, I would say we can merge it backwards. I hope the same for our Pharaohs, but we'll see about that.
In the beginning, you had a slide with the size of different Wi-Fi drivers.
Yeah.
And you mentioned the size explosion of the Intel drivers. I'm curious, we've known that Intel drivers for Ethernet are not terribly efficiently written. Like if you compare the Intel driver used by FreeBSD and the custom written version in NetBSD, they are like an order of magnitude difference in code size and in binary size. Do we have any evidence that the wireless drivers are actually worse their size, or that they are not just big and bloated?
I wouldn't say big and bloated. I would just say Wi-Fi got complex, and that's where it comes from. Ethernet, to me, sounds a lot more simple. Most of that is offloading. IWL Wi-Fi would have TSO offloading in the driver, for example. If you would drive it, we could do. But at this point, I think people are more happy to get the 1 gig of Wi-Fi speed, and we'll sort out other problems before we go into individual features in Linux KPI and drive that. Yep.
So suppose you were to do a homebrew operating system and you wanted to add some sort of Wi-Fi support. What would be like the easiest card to write a driver for if you just want any Wi-Fi card supported on your own custom operating system?
The easiest driver to do, yeah, I can tell you that. We've removed it from the tree, but do it for that one. Realistically, these days, if you just want to pass packets, I don't know. The problem is, if you strip them down and do them natively, like IWX was done from OpenBSD, you have a lot more chances than going for Linux KPI if you really want to be minimalistic and pass them. If you want client support, I would go with Intel because it's just the predominant chip at this point.
You can use the 9-front Intel driver.
Yeah.
9-front has a small Intel driver. It's funny to read.
Yeah, we had this discussion last night as well. there is an abstraction for the Intel driver where you can drive it from user space. So that's also a funny experiment. Well, I'm way over time. I think more is to come next year. Thank you all very much.
the cluster admin team. I believe in open source resilience, long-term stability, and therefore I occasionally break things, but only in the name of security and innovation. I have also served on port manager, and I have spent years maintaining, patching, cleaning, and sometimes surgically removing parts of the port tree. So what I'm going to share today isn't actually an abstract. It comes from direct experience. So why this matters? The ports collection is not just a convenience for end users. It's how FreeBSD users interact with the broader software world, whether it's a web server, it's a mail stack, development toolchain, or a desktop. People install it through ports or binary packages. So when the tree actually starts carrying more risk via deadwood, users inherit that risk, silently and often realizing that they are doing that. And in today's world, the risk actually doesn't just mean something that might crash your application or crash your service. It means your supply chain might be vulnerable. It means that compliance expectation might not be aligned. It means that one outdated component, one forgotten port could become a lucrative attack surface. Ports or packages are actually part of the base system's trust envelope, whether we like it or not. Let's look at a scale for a moment. In 2005, we had about 10,000 ports. 2015, around 25,000. Today, around 35,000. And the number is actually still growing for the FreeBSD ports tree. Now, growth isn't actually bad, but scaling changes the rules. A process that works or worked for 10,000 ports might break down at 30,000 unless you rethink governance, testing, and curation. We are still running much of the ports tree as we used to do in 2009. We have added automation and some sort of CI in some places, yes, but not across the entire board. And our policies are yet to catch up with this new scale. One of the biggest mindset shifts we need is this. FreeBSD is not GitHub. We do not need to port each and every software that is in GitHub into FreeBSD ports tree. It's not Pipey, it's not Ruby gems, and it should not try to be. More packages doesn't mean better. Having 35,000 packages that build is not a metric of success if a good chunk of them are actually outdated, insecure, or entirely unmaintained. We are not a package mirror. We are a curated operating system. And that means that we have a responsibility to say no to some things, or at least not say yes by default. Not say yes without further thought and some reasonable analysis. So what happens when you scale to 30,000 plus ports without scaling the rest of the system? You get trade-offs nobody signed up for. Security starts losing to compatibility. Governance gets overloaded. Volunteers are actually trying to cover too much ground. CI and quality assurance can't catch regressions in time. Tooling gaps grow wider. We still don't have a reproducibility guarantees, although around 92% of the ports on packages are actually reproducible, or SBOMs, or any sort of provenance checking. And most importantly, the energy actually starts flowing into where the excitement is. These days, that's often the desktop side of the ecosystem, which is fine, but it actually pulls focus away from the core software and the long-term maintainability of software. Let's talk about something a bit very much sensitive, commit quality. We have all seen this, drive-by version bumps, no testing, no rebuilds, sometimes even major language or library upgrades without checking what breaks the downstream packages or downstream ports. And here's the thing, I'm not against automation. I use it myself. I have done thousands of automated hygiene commits, but the difference is actually discipline. Every commit is tested, rebuilds are checked, quality assurance is done beforehand. The automation isn't the problem, the absence of the structure and governance around it is. What we are actually missing is a project-wide standard for quality assurance in the port tree. There is no required reproducibility builds. There is no checks that reverse dependencies are still building after a port upgrade or after a fix. There is no policy for provenance or review on critical ports, so we get breakage silently and silent regressions and a lot of shrugging between developers. And here is why this isn't just an annoyance, it's actually a supply chain risk. Today's users, especially in regulated or enterprise environments, are looking for reproducible builds, software bills of materials, provenance, and signature tracking. We are unable to offer any of these consistently from the ports we currently have. If a vulnerability like the XD backdoor had landed in one of our packages, would we even be able to trace it? Would we know who committed what, when, with which inputs? We are actually operating below the minimum standard the rest of the open source world is moving towards. And if you want a concrete example of legacy risk, look no further than Python 2.7. It has been end of life since 2020. Upstream doesn't patch it. Major distros have dropped it. Yes, we still carry it because of long-tail dependencies like Mailman 2.x or Moin 1.9.x. There are still real-world systems, even production ones, that rely on this. And we are keeping it in the tree because someone still needs it. But at some point, we need to ask, are we carrying technical debt forward or importing risk we don't understand at all? We'll return to that thought at the end. Let's look at some more examples. Let's talk about libxml2, a library so foundational that almost every serious stack actually touches it. It's critical for parsers, XML processing, a lot of older desktop apps, even things you don't expect. But right now, we can't update libxml2 easily. Why? Because the update actually breaks other ports, usually ones that haven't been maintained in years. And so the update gets stuck. It sits in the queue. What more important is shipping security fixes for a core library or keeping something that actually depends on an ancient patch set from 2014 building for a little longer. This is the kind of trade-offs we are silently making, and users don't even fear it. A quick side note here, libxslt, which is closely related, recently had a critical CVE. Upstream has gone through some churns. The old maintainer stepped down, a new one came in, and several Linux distros like OpenSUSE, Debian, OpenBSD have fixed security patches. We haven't picked them up yet, not because we are careless, but because nobody owns it. It's just sitting there, quietly vulnerable, quietly broken. And it's just not libxml2. Let's name some names because it's important to be specific. GTK2 is still there. PCRE 1.x library is still here. Rails 7.0, now UL, but it's still here because GitLab depends on it. GitLab has not yet been able to update their software stack to the latest Rails versions. PHP 5 era CMS ports is still here. Custom forks of unmaintained software is still here because someone somewhere still builds it. And it's understandable to want to avoid breakages, but we have quietly shifted into a mindset where the cost of the removal is too high. So we just stopped removing things. But here is the catch. The longer you delay, the harder it gets, because more new things get added that depend on the old stack. Let's talk toolchains. We now have 12 versions of LLVM in the ports tree. That's not just technical debt, that's technical sprawl. It increases build times, binary sizes, CI complexity, and security surface. And there is no life cycle, no clear deprecation path, no plan that says if you are not using LLVM XY, it's going away in 12 months. Why? Because some leaf port depends on LLVM 11, and nobody wants to touch it. And that brings us to what I think is the hardest part of this conversation, governance latency. This isn't a staffing issue. People have stepped up to clean things. Some of us, myself included, have submitted removals for long dead ports. Sometimes it has been automated, scraping GitHub commit logs and to check which upstream packages are maintained and not maintained. Sometimes it's been manual after deep review, but very often those efforts were blocked. Why? Because someone said, well, it still builds. Someone somewhere might still use it. And at some point, that logic becomes toxic. It stops us from doing actual stewardship. You can expect high quality curation while putting a veto on removing outdated and possibly vulnerable softwares. That's not sustainable governance, that's fear-driven compliance, actually. And while we are spinning in circles about whether or not to remove PCRE 1.x, the rest of the world is actually moving on. The XZ backdoor wasn't just a wake-up call, it was a proof that small invisible components can be existential risks, and governments have noticed. The EU CRA is coming, the US has minimum secure software standards by NIST. Customers are asking about SBOMs and supply chain audits, and we are not ready. Not because we can't be, but because we haven't made it a priority. And our size, our sprawl, our lack of removal policies, those are blockers to becoming a modern, trusted packaging ecosystem. So we are actually not alone in facing this kind of problem, but other projects have made different choices. OpenBSD, for example, keeps their ports or package tree very lean. They value code quality and trust over quantity. Things that don't meet a high bar just don't stay. Arch Linux tires their packages clearly. You know, like what's in the core, what's community, and what's unsupported. Debian has made real strides in reproducible builds, and they are ahead of us in that respect, although they are suffering from 70,000 packages, I believe. And none of them are perfect, but all of them actually have recognized this reality. More is not always better. Curation matters, and tiring matters. Life cycle matters. So what we can do about it? Here are a few actionable and non-radical suggestions. First, introduce tiring inside the ports collection. Not everything needs to be treated equally. We could have a core tier, well-maintained, reproducible, CI-covered, an extended tier which includes useful software with less stringent guarantees, and a community tier unsupported but still present, similar to Arch Linux user repo or homebrew casks. Then set some actual life cycle policies. When an upstream is EOL, we start a clock. That doesn't mean we remove it overnight, but it means we stop pretending it's fine to keep forever. Start requiring reproducibility, at least for the core tier. If it can be built reproducibly, it doesn't ship in core. Support SBOM generation, which is ongoing, and some basic provenance tracking. We don't need a full supply chain system on the day zero. Even minimal metadata is actually a very good start. The foundation could consider investing developer time or grants in core infrastructure and cleaning up not just new features in the port tree. And finally, the governance needs a visible published roadmap for these things. If the community sees direction, they will support it. But if nothing moves, people disengage, or worse, they actually fork very quietly. And now I want to leave you with a serious question. We were lucky with the 4chan incident. The exploit hit an unsupported version of FreeBSD and an unsupported version of PHP. It was bad, but it was also technically not our problem. But what happens next time? What if the next compromise targets Mailman is still running on Python 2.7 on a supported FreeBSD release with a port that is still in our port tree? What does that headline look like? Because that's not a theoretical anymore. That's a configuration some people here may still be running. We are stewards, not archivists. We are not here to preserve broken software for eternity. We are here to curate, maintain, and evolve a system that users and the world can trust. So let's talk. So before we open up for the discussion, I want to leave you with a few questions, not rhetorical, I mean actually reflect on these. Do you trust your pipeline to catch transitive vulnerabilities? When was the last time you checked if Nginx, Postgres, or your mail stack was indirectly pulling in outdated unpatched libraries? What do you do if a critical user-facing application in your environment depends on a vulnerable version of libxyz and no one upstream is actually fixing it? Do you patch it locally, drop the port, wait and hope? These are the kinds of decisions we are making, sometimes unknowingly, every week, every day. And the more we automate around them without a strategy, the more risk we simply silently accept. So that's why I actually wanted this room to talk and have a conversation. Yeah, that's a fantastic idea, like having, like if someone wants to override the original flag and say like allow UL ports, yes, only in that case it will be built. We can disable that flag in the cluster so that package will not be built. But I just want to say, like, I have been maintaining PHP ports for a couple of years, and as I mentioned in the presentation, I am also very much strict with my EOL dates. So whenever the next EOL of the next version of PHP is announced, I put it in the ports tree. And I think like I have maybe hundreds of more mails just to say, it's 1 year after, why do you need to have the deprecation notice now? And when I didn't have it, I used to have mails like, hey, you just deleted the PHP ports after 1 month of notice. So yeah, there is both part of the story, but this is a really good idea I would like to discuss and implement. I actually don't have a mic here, and I don't know, like.
Hello. So, thank you for this, rising this up, but I think that the problem is more like in the outside world than in the ports tree. The way I see the problems you described is it's like more of a communication problem, that we don't communicate to the user that, let's say, this is a risky port, for instance, because, for instance, I myself use programs that rely on GTK2, and I want this tiny apps because they are tiny and they are speedy and so on. So, and even if they are deleted from the ports tree, I will have my own ports overlay to compile them and install them as packages. So, if we have currently like Go ecosystem or Rust ecosystem or NPM ecosystem and so on outside of the port tree, and this is where the risk comes to the port tree. That's how I see it, and it's more like the port trees management should be more vocal about quality of outside world than the ports, because it's not about the ports themselves so much as much as the quality of what we are porting to FreeBSD, to run on FreeBSD in let's say managed way.
Yes, thank you. So here is a different part of it. So what happens is when like FreeBSD port system had been supporting ports overlay for quite a time, and that means that you can actually have your customized ports tree on top of the original FreeBSD ports tree. Now there are two different problems here. The problem is like when you are officially creating FreeBSD signed packages and distributing it to the end users, and an enterprise is actually installing that vulnerable version or Python 2.7 in their ecosystem versus a company deliberately having a customized ports tree, building their own packages and installing it from their package repo. So these two are two different cases which needs to be addressed differently, because what happens is most of the people even do not understand the reality that a small vulnerability in a small library can actually cause mass catastrophe on a larger scale, whichever they are actually using in a public-facing service. So at least like if you say about GTK2, I think there is a wiki page, and I have tried, at least like I do not actually own any more ports which is based on GTK2. I have removed all of my ports, or maybe I think someone took over my ports. But there is actually an EOL notice for GTK2, but if I try to remove a port which is unmaintained, someone will say, hey, I use it.
What's your take on the XZ Trojan? Because basically, when it came out, I looked at it very closely, and it's terrifying. Absolutely no idea how any port system could cope with that. You got a guy or an organization who manages to make patches that sounds legit and are actually legit, then takes over maintainership, then hides that Trojan in the test suite that nobody looks at, then finally makes a release with a very slight tweak to configure that was never committed to Git, the kind of stuff that nobody tests, that nobody looks at, and also with part of the configure being designed to only activate if you're running on a very specific system and in batch mode. Any idea how we could manage to get that?
No, I do not have any idea about that. But what happens is, what we could do, like if let's say about libxd or some other ports, we can actually mark it broken, like maybe like with something, it's vulnerable or something like that. So whenever some other ports which are actually being based on that port, the other ports or packages will not be built anymore. So that is one thing. And if you are saying about testing, this is a very few thing actually, very few developers in our ports to actually do. That is another problem. Like we can just see, as I said, like commits with just disinfo update and no version, like which is actually not even building properly. No, not at all.
And this is something that we should, at least on various systems, try to do. Check randomly, maybe, if something changes. If you catch some other issues, I guess it was, I don't remember which ecosystem, but there was a point where you had somebody redirect package repository elsewhere to the this version for maybe 1 hour, just long enough so that the actual package in the cache would be the wrong one, and because they don't have a supply chain problem, have enough checksums, we got caught by it. So this is maybe the kind of stuff that we should do more random testing.
Yeah, it depends. Like I think I cannot see Rodrigo here. So a couple of days ago, we had someone trying to fork a project and demanding it like, I have forked the project, I have written to this official maintainer, and the official maintainer has not responded to my mail, but so I'm taking over. So like, there are compliance to licenses and everything. You cannot just take over a port which is maintained by someone else. And some committer was actually about to commit it before someone stopped him from committing. So yeah, things are risky. So there are like, I know that even in OpenBSD, FreeBSD, NetBSD, all the committers who are actually brought into the platform are very much well deserved, I would say, and I would say like they are very much expert in their domain, but there are things which they do not comply to, they do not do. And we cannot enforce it.
So I do have a bit of another perspective on the whole collection of unmaintained software thing. We are looking at things like GTK2 that have been end of life for a rather short time, but meanwhile we still ship things like Athena widgets which have been obsolete for longer than some of us are alive. The value of the port system is that useful and important software is present, and for much software the user doesn't actually give a fuck that it's unmaintained or has security issues. If I need a very specific piece of software to maybe operate on a very specific file format or something, I don't care that it's unmaintained. I don't care that it has security issues. It's not going to reach the network. But if it wasn't there, it would be a big headache to me. Another example for this is like open source video games, which usually have a development cycle where someone writes this and then the source code is there and people like it, but it will never be developed again because the game is done, the feature set is done, and if you put on the same standard like, oh, it's not maintained, we have to throw it out, that means software people love and use gets thrown out just because there's nobody upstream constantly like pushing bits back and forth for no reason at all. So there kind of needs to be a weighing of of the values. So for which ports is security and reliability the key value, and for which ports is their sole presence the key value. So it would be interesting to kind of think about this in the grand scheme. Because we can't just throw out the baby with the bathwater and say everything that's unmaintained has to be thrown out, and so lots of software people actually like gets thrown out just because there's no upstream.
Here is actually... Okay, one thing I would like to say about this, like, let's talk about two pieces of applications. QMail, TinyDNS from Dr. J. Bernstein. So what happens is the original software still works, no offense, but what happens is, and he has actually, I think, a huge amount of bounty on that applications. So that those are not vulnerable and will not be. But the problem is in our port tree or in any third-party operating systems, package systems, it's actually not the original software that is actually there. There are third-party patches which are actually included in those binary packages, which does not ensure what Dr. J. Bernstein actually promised to us. So while you are right in one sense that a software works, and we have removed such softwares, but we should actually balance in that part, like where security actually becomes part of security, I think.
Yeah, put it in the community, like the different tiers. There are paradoxes here, if I may, because we are talking about unmaintained software, about software that is kind of abandoned by the original creator. But at the same time, we have important programs that are actively developed in like a 6-week release cycle that are great projects in the sense of code base. And for instance, Chromium. It was probably the last application on Earth that migrated away from Python to build system. This is one thing. Now it's huge program, it's huge browser, it's important for many people, but at the same time, I can't remember a week when the package was not marked as vulnerable. What do we do about this? When the original creator, a huge corporation, doesn't give a dime what's going on with the problem?
Okay, in FreeBSD, we actually do not exactly track CVEs. So what we have is actually an application called View XML, where we actually put the CVEs. And developers and port security team are supposed to actually check, I think, and add those vulnerabilities there. But often, like, I don't know, some people think that writing XML is difficult in today's world. Yes, so, yeah, you can see that. So, yeah, you can see that. Okay, good news for all of you who actually hate to write XML, that we are actually migrating to OSV scanner.
What I'm missing in this kind of discussion is software can be unmaintained, but what is the risk it is actually presenting? GTK2 has been mentioned. Generally, GTK2 software provides a very small actual attack surface, because the most dangerous thing that can happen to your GTK2 program is generally your own cat. Same for Python 2, for example. If you look at the history of Python, the number of actual exploitable bugs that don't fall into the DOS category. I would explicitly exclude that for various reasons in general. Is very small. We are generally talking about 1 or 2 issues at most per year. And those issues generally apply to most of the code base. So all Python versions at the same time. So I don't consider Python 2.7 especially risky as a dependency. So yes, as a commercial user, I want to get rid of it, but if you have a large Python code base, that's complicated, that's expensive, that requires dealing with customers to get them to update. So of course it's a long-term project. So saying you need to get rid of it now is not a very productive thing to tell a user of the ports infrastructure. So that's the other side of the medal.
I think like you are actually trusting a currency called hope in the days of time in the world we are living where security, like we cannot actually trust anyone.
Right. If I may just point out one thing, you mentioned that there is very few vulnerabilities. I'd like to add that we know of. If you are building on Python 2.7, there are lots of projects that are built on Python 2.7. One vulnerability in Python 2.7 affects most of them. And then you are looking into a client base, which is quite huge, but then they're all vulnerable. These are the things, I think, what has been discussed, that how can we get out of that system whereby I'm having to rely on a ports tree, and I trust the ports tree because I had been using FreeBSD for many years, and I'm having to wonder how many others that I'm not aware of, which might bite me back at some point or other. And if I may just change the topic slightly differently, I come from an institute which is focusing mainly on compliance and other bits and bobs, and I'm beginning to wonder, through this conference so far, what I have noticed is that a lot of effort and investment is actually going into the laptop, wireless, desktop side of things. I maintain an infrastructure. I offer services to a few thousand people, none of who cares about a laptop, desktop, or something running in FreeBSD. They have stable systems, they are happy with their systems, and I would love to have a system that can serve those people stably and securely. Will I be correct in assuming that the foundation has actually changed its focus from the infrastructure market to the desktop laptop market? Just curious.
That's actually a question which is beyond my pay grade because there are interests in that market, and I think there are some sponsors also working on desktop based on FreeBSD. So yeah, I cannot actually answer that question, sorry.
I wanted to come back to the issue of Chrome because I think it's a very important issue. The main problem is not that any week you've got some vulnerability in Chrome. The main problem is that it's not free software, not for real. You've looked at the port on FreeBSD, right? It's the same port in OpenBSD. It's the work of Robert Nagy, who is maintaining something like 1,000 patches for Chromium. You know why there are so many patches? It's because he talked to Google, and Google said, fuck you. We don't care about BSD. We won't upstream the patches because this is not a tiered platform. And this is a big issue. There are a bunch of software. Most prominent might be Chromium, but LLVM in some cases, GCC. They are all stuff that are maintained by big corporations. It's no surprise that GCC is maintained by former Red Hat and now its owners. And if you want to work with these people, it's a full-time job, more or less. And this is a big issue for us because they have open source licenses, but actually they don't play with us. They have lots of money, lots of ways to do whatever the fuck they want. Like for instance, if you're using Chromium a few months ago, you discovered that suddenly you couldn't use uBlock Origin anymore. And you know why, obviously, because it would allow you to remove ads from YouTube. And YouTube is also owned by Google. So at some point, either we make a stand and we try to, I don't know, change the PR word, because the spin currently is that, Google are the nice guys and they open source Chromium, but it's bullshit. Or we just drop them and put all our efforts in stuff that does deserve it, like Firefox, for instance. Thank you.
Yeah, there are actually a couple of ports and applications which take a huge amount of time in our cluster build system, which includes multiple variants of Google Chromium, ungoogled, and then there is, yeah, that's, yeah, so, and what happens is like most developers even do not have that enough hardware resource to compile it by themselves. Because I think like most of it actually, it opens like 2 million files or something like that. And beside that, one of the, yeah, exactly. So even Zcash is also actually not very much helpful in those cases. Yeah, but I think there is an alternative to that. Like nowadays, someone was talking about Zcash or something like that, but I think like it's unmaintained nowadays. So the alarm has rang and we have run out of time. Thanks to everyone, and if you want to catch up, I'll be at the social and also tomorrow here and we can discuss more. Thank you.